This question asks us to find the angle and standard position of a displacement vector delta r, given that the displacement is in component form -5, 4. All right, so one of the first things we'll want to do is think about what quadrant this vector points toward. If we draw just the x and y axes here, and let the tail of our vector be located at the origin, then we can draw this vector in the same way that you draw a coordinate pair. We'll go to the left 5 according to that, and then we want to go up 4. That'll take us to the point -5, 4. Alternatively, we could have gone up first, 4, and then over to the left 5, and we still get to the same point. So we want to start our tail here at the origin and just point to the location that we ended up at. And that's going to be our vector delta r. It is, of course, -5, 4. Now, what is the meaning of those numbers? The -5 would be here, and the 4 would be this side of the triangle. And now we want to find an angle from that. I'm going to use the formula beta equals the tangent inverse of the y component here over the x component, but we use absolute value because we don't want any negatives in this formula. So let's plug in. The y component is going to be a 4, and then the x component is -5, but the absolute value signs make it positive. I get 38.7 degrees. It's important to note that this formula does not always give us the standard position angle. There's a two-step process to finding the standard position angle. What beta is actually a reference angle. Now, what exactly in mathematics is a reference angle? Well, if you were to look at the 4 quadrants, and think of all the possibilities of vectors that we could deal with. We could get a vector that points toward the first quadrant, or we might get a vector that points toward the second quadrant, maybe one that points toward the third quadrant, or even one that points toward the fourth quadrant. Now, if you do this formula for beta, for the first quadrant, then beta is the standard position angle because it's measured counterclockwise from the positive x direction. But what beta gave us here is the angle that our vector made with the x-axis, which is not a standard position angle. It's a reference angle. And if we were to use it on a vector that points in the third quadrant, it would also give us the angle that that vector made with the x-axis. And the same thing would happen here. It's what it always gives us. So we have to make modifications depending on which quadrant we're pointing in to find that standard position angle, because the standard position angle is always measured counterclockwise from the positive x direction. So hopefully you can see here why the 38.7 that we got is not the final answer. So what we got to do is we have to go, there's a guide for it. Right here is the guide, which says that, so if we're in quadrant 1, then our standard position angle is the reference angle. that would be this case here. Beta is theta. They're the same. But if we're pointing in quadrant 2, we have to make a modification. Beta is going to be here. So we have to do 180 minus beta to get the standard position angle, which would be measuring it all the way around from the positive x direction. If our vector points in the third quadrant, then we're going to do 180 plus beta. That's this one here. And if we're in the fourth quadrant, we'll do 360 minus beta. It should be clear from the diagram why that would work. So we are pointing in quadrant 2 with our vector. So let's use the formula. Theta standard will be 180 degrees minus beta, which is going to be 180 minus 38.7. So our standard position angle is 141.3 degrees.